This lesson is about end behavior and graphing polynomial functions. So your essential question is, why is it helpful to know end behavior? So in this section, we are going to be graphing polynomial functions that look a lot different than quadratic functions, which we've done before, which are parabolas. We're going to be graphing stuff that looks pretty crazy, such as like f of x equals x to the fourth plus 2x cubed minus x plus 1. And we can graph this. And so it's helpful for us to know what the ends of the graph are going to do. That way when we're plugging in points, we don't have to just plug in millions of points so we know that we've got the whole thing. We know that if we know what the ends do, then we can kind of anticipate what the graph is going to do. So end behavior is what happens to a graph as x approaches infinity or negative infinity. So when you think of this, if you were to think of a graph, x approaches infinity going in the positive direction. So here's the x-axis, and if I'm going this direction, if I'm moving right across the graph, that's going towards positive infinity. And if I'm moving left across the graph, then that's going towards negative infinity. So when it says x approaches infinity, that means the graph on the right side. And when it says x approaches negative infinity, that's talking about the graph on the left side. So these are the end behavior of polynomial functions. If the degree of our function is odd and the leading coefficient is positive, then this is what the end behavior does. It will go down on the left side and it will go up on the right side. Now it can do all kinds of crazy things in the middle. We're just talking about the end. So this is just one example. So for example, if I have f of x equals x to the fifth plus 2x cubed plus 3. This would be an example where the degree is odd, because we have 5 as our degree, and our leading coefficient is positive. So we just have a 1 representing x. So in front of our leading coefficient is 1, is what I was saying. So then our degree is odd, our leading coefficient is positive, so we know that it's going to be going down on the right side and up on the left side. So it kind of makes a snake. And it can do like this in the middle, it can bounce up a whole bunch of times like this. You don't know. All you need to know is that the left side goes down and the right side goes up. So, let's back up just a second. When I'm looking at this is kind of confusing. It says f of x approaches negative infinity as x approaches negative infinity. Now that means a whole lot of crazy things to me. So to break this down, f of x is talking about our function, which is the actual blue line of the graph. So what is this? It's saying is that the graph f of x goes down towards negative infinity as x approaches negative infinity. So on this side, remember how we talked about x approaching infinity or negative infinity? So x approaching negative infinity is talking about the left side of the graph. So it's saying, what is the graph doing on the left side? Well, the graph is going down. So f of x goes towards negative infinity. For this one, as x approaches positive infinity on the right side of the graph, our blue line goes up. So f of x approaches positive infinity. So that's what that means. It's kind of confusing, I know. We will talk about the other ones and get some more practice. So if our degree is odd but the leading coefficient is negative, what's going to happen is our graph is going to flip around. So instead of going positive like this, like a snake, kind of going like this, it's going to go down like this. So what you need to know is that if the degree is odd, for example, if we have f of x equals negative 3x cubed plus 5. This would be an example where our degree is odd, because we have 3, and our leading coefficient, the number in front, is negative. So when I'm talking about these right here, as x approaches negative infinity, that's talking about the left side of the graph, what happens? Well, it goes up. so f of x approaches infinity. And as x approaches infinity, going the right side, the blue line goes down, so f of x approaches negative infinity. So x is referring to, x approaching infinity is referring to the right side of the graph. X approaching negative infinity is talking about the left side of the graph. And you just have to tell if f of x goes up or down. So let's talk about the last ones. If the degree is even, so something like f of x equals x to the 6th minus 3x to the 4th plus 2x squared minus 5. So our degree is even because we have 6 as our highest exponent, and our leading coefficient is positive. The number in front is a positive 1. What happens is both ends go up, so it makes like either a W shape, or if it was like x squared, we know that that makes a parabola. So you can remember that if it's even, it's like a parabola. It goes up on both sides. Now, if it's x to the 6th, it could have all kinds of squigglies in the middle and be something weird like this. We don't know. But we know that both ends go up. So that's what's important. And so, as x approaches negative infinity, the left side of the graph, what happens with our blue line? It goes up. So f of x approaches infinity. And as x approaches infinity, going to the right, f of x, our blue line, goes up. So both of these are going to be positive infinity. Now the last one is if it's negative. Well, if it's even and negative, it just flips upside down. So, for example, if I had f of x equals negative 2x squared plus x plus 3, well, I know my degree is even because I have a 2, and my leading coefficient is negative, so it's going to be upside down. So this would be like an upside down parabola. It's a quadratic, so we know it's a parabola, and it's going to be upside down because the leading coefficient is negative. So we know that both ends go down. So as x approaches negative infinity, going to the left, our blue line goes down, so that means f of x approaches negative infinity. And as x approaches positive infinity, going right, f of x, our blue line, goes down towards negative infinity. So they're both the same. So to recap really quick, if the degree is odd, remember it's going to make a snake of some sort. We don't know how many bumps are in the middle, but it's going to go from left to right like this. And if it's negative leading coefficient, it just goes backwards. If it's even and positive, it both faces up, kind of like a parabola. And if it's even and negative, it both faces down, like an upside down parabola. So those are some ways to remember end behavior. Now we're going to actually get into graphing. So how the heck do I graph a function like this? It's pretty crazy. So I have f of x equals negative x cubed plus x squared plus 3x minus 3. That's a lot of stuff. And I don't know how many bumps it has in the middle or anything like that really for sure yet. So the only thing I can do is plug in points. And I kind of just make it a general rule to plug in from negative 3 to positive 3. So you can make a chart, and we're just going to plug in numbers for x. Okay, so if I plug in negative 3, then in my calculator I'm going to take negative, and then I have negative 3 for x. So you have to have two negatives because there's a negative sign already there. And then you put parentheses wherever the x would go. And then cubed plus negative 3 squared plus 3 times negative 3 minus 3. And I can plug all that into my calculator as long as I use parentheses, and I'll get the right answer. And so I'll just check, and I would get 24. Then I would repeat the process, and I would plug in negative 2. So I have negative 2 cubed plus negative 2 squared plus 3 times negative 2 minus 3. So you can work this out, or you can just use your calculator. And we get 3. Okay, and if we continue this process, These are the answers you would come up with, plugging in numbers from -3 to +3 for x. And so I'm just going to graph these points. But before I just go ahead and graph these points, I'm going to check and see what my end behavior would be. So if I go back to my function, my degree would be odd or even. If I look here, my degree is odd. And my leading coefficient is negative. Sorry. So that means what shape is it going to make? It's going to be like a snake, but it's going to be backwards. So it's going to look something like this. And it might have a lot of bumps in the middle. I don't know. But it goes like this. So it goes up on the left side, and it goes down on the right side. So when I graph these points, I know that as x approaches -infinity on the left side, my graph goes up. And as x approaches +infinity on the right side, my graph goes down. So I'm going to just graph these points. So let's go back up so we can see our points. I can't graph -324 on here, so I'm just going to leave that. But I know it's going to go way up high. Then I have the point -2, +3. And then I have the point -1, -4. And then I have 0, -3. And then I have 1, 0. 2, -1. And then 3, -12 would be down there. Now I have to connect the points going from left to right. So right now, when I connect them, it's going to go like this. And then I need to know if my graph continues to go up or if what happens. Well, I know that -324 would be way up here. So it's going to go like that. And I know that +3, -12 is going to go down. So it's going to be way down here like this. And my graph, if I just leave it like that, it shows the correct end behavior. So I know I did it right. So really, I'm just plugging in numbers, but I need to check the end behavior, because if let's say my end behavior went down on the left side, then I would know that I would need to plug in some more points until it goes down. So that's just something to think about and why it's helpful to know end behavior. So let's try another example. Let's graph f of x equals x to the fourth minus x cubed minus 4x squared plus 4. So same process. We're going to plug in points again, and I'm just going to kind of use my general rule of plugging in from -3 to +3 for x. So when I plug this into my calculator, I'm going to have -3 to the fourth minus -3 cubed minus 4 times -3 squared plus 4. And when I check that answer, it's going to come out to be 76. And if I plug in -2 the same way, -2 to the fourth minus -2 cubed minus 4 times -2 squared plus 4, I should end up with 12. And you can continue this process, and please stop and try and check this in your calculator, because what I've noticed is that a lot of people make mistakes because they think they're doing it right and they put it in their calculator and really you're putting it wrong. So please at least try a few of these and check and make sure that you're getting the correct answer. So then we're going to check end behavior. So if we look at our function, is our degree even or odd? It is even. And is our leading coefficient positive or negative? Well, the number in front is just a 1, so that would be positive. So what does the end behavior do? Well, remember, if it's even, it's kind of like a parabola, and it's positive, so that would mean that it would face up on both ends. So as x approaches -infinity on the left side of the graph, it's going to go up, so f of x approaches infinity. And as x approaches +infinity on the right side of the graph, it also goes up. So both ends go up. So let's graph some points. So we have -376, can't graph that. -212 won't fit on our graph either. So we have -1, 2. 0, 4, 1, 0, 2, negative 4, and 3, 22. So if I connect them as it is right now, it would go like this. And I would have the point negative 376 to graph on here, but I can't graph that. I also would have negative 212, but I can't graph that. So somewhere in here, if I was to graph negative 212, that would be like way up here. So somewhere along this line, this goes back up like that. And after negative 2 or positive 2, negative 4, I have 322. So it would go way up like that. So as you can see, this graph kind of makes a W shape, but the end behavior goes up on both ends, so I know that I did it correctly. Please go ahead and write your summary and make sure that you answer the essential question.